welcome to this explainer. Today, we're going to build the absolute ultimate high-level strategic playbook for acing the modern system design interview as a veteran Java tech lead. Now listen, if you're sitting on around 14 years of experience, we already know you know how to code. But proving you can architect scalable, resilient, and modern distributed systems in just 45 minutes, that is a completely different game. So we're going to distill the must-know patterns, the modern Java-specific toolkits, and the exact frameworks you need to clear today's incredibly high bar.
Okay, let's dive right in by asking a pretty tough question. Do you actually have what it takes to clear the 2026 hiring bar? Because let's be real, the hiring landscape has completely shifted. You might have coasted through system design rounds a few years ago by just throwing a load balancer and a cache up on a whiteboard, but those days, yeah, they're gone. Today, interviewers are looking for a completely different level of operational maturity, especially for senior and tech lead roles.
What's really fascinating here is that simply passing the technical bar is no longer enough. You have to stand out against this massive pool of highly qualified candidates. I mean, look at this quote from an Airbnb engineering interviewer. They noted that candidates who would have easily been a strong hire 2 years ago are now barely hitting the hire mark, and they're often getting declined when final offers go out. The competition is just fierce, and the margin for error is essentially zero.
So how exactly do you stand out? Well, interviewers aren't just looking for basic scale anymore. They want you to demonstrate operational maturity, a deep reasoning about cost, and the ability to handle modern AI infrastructure. If you get a bottleneck and just say, oh, we would add more servers, you're going to fail. You need to confidently discuss when to use spot instances, how to monitor for cascading failures, and even how to design systems that handle massive async workloads for large language models. Bringing up observability, metrics, and tracing unprompted, that is a massive green flag. Section 1. Essential Microservice Patterns for the Tech Lead Toolkit. Let's see how this all builds into our architectural choices. These patterns right here are your tried and tested solutions for building robust, decoupled systems. First up, we have polyglot persistence. As a tech lead with over a decade of experience, you need to confidently recommend this, showing you know exactly which database engine fits a specific workload. You just can't use Postgres for everything anymore. If a microservice needs high-speed caching, you suggest Redis. Heavily relational transactional service, you use SQL. Managing massive, flexible document structures, maybe MongoDB. You really have to prove you can match the tool to the specific storage and query capabilities needed. You also absolutely must master the circuit breaker pattern. Why? Because great system design isn't just about the happy path. It's about designing for when things inevitably break. Inspired by literal electrical circuits, this pattern monitors a service for failures. If the error rate crosses your predefined threshold, the circuit opens. This instantly blocks further requests, which gives that failing service time to actually breathe and recover, rather than suffocating it with retries. And this is absolutely crucial. Failing to isolate dependencies leads to massive architectural debt and cascading failures, which is exactly what your interviewer wants to see you avoid. I mean, research shows that tightly coupled systems experience 2.6 times more defects and require up to 8 times more engineering hours just to make modifications. If you don't implement patterns like circuit breakers and bulkheads, literally one single synchronous API bottleneck can take down your entire infrastructure. Section 2, Distributed Transactions and State Management. Let's tackle one of the hardest parts of distributed architectures. This is where senior candidates really prove their worth. This illustrates a massive paradigm shift from the synchronous, blocking two-phase commit to the decentralized, event-driven Saga pattern. On the top, you've got your traditional two-phase commit. It locks resources across multiple services, which is honestly a total nightmare for horizontal scalability and availability. But on the bottom, we see the modern Saga approach, a chain of independent, local transactions that just communicate via asynchronous events. So why does this matter? Because interviewers want to see how you achieve eventual consistency and high scalability by pairing that Saga pattern with CQRS and event sourcing. CQRS allows you to scale your read-heavy user interfaces completely independently from your write-heavy transaction logic. And when you combine that with event sourcing, where every single state change is saved as an immutable event in a log, you get perfect auditability. Plus, you get the ability to instantly rebuild your system state from scratch if a microservice goes down. Looking at this workflow, you can explain exactly how local transactions triggers subsequent steps via a message broker, and then use compensating actions if a step fails. For example, an order service creates an order, then fires an event into Kafka. The customer service picks that up, tries to reserve credit, and fires a response back.
Now, if that credit reservation fails, the Saga pattern ensures a compensating transaction is sent back to the order service to cancel the order. No global locks, no massive bottlenecks, just graceful, eventually consistent architecture. Moving on to Section 3, Modern Resilience in Spring Boot 3. Let's bring all this directly into your daily Java stack. As a Java tech lead, your interviewer expects you to know the current ecosystem, not just the abstract theories. Listen, if you mention Netflix Hystrix in a 2026 interview, you might show your age. It's been in maintenance mode since 2018. Resilience 4J is the modern, actively maintained standard you need to be recommending. Hystrix used heavy thread pool isolation and had timeouts built into every command by default. But Resilience 4J? It's a lightweight, modular library built for modern Java. It uses semaphore-based isolation, meaning threading is explicit and totally up to you. Now, what's really interesting here is that demonstrating this direct property mapping proves deep, up-to-date domain expertise. For instance, if you know off the top of your head that Hystrix's error threshold percentage is directly replaced by Resilience 4J's failure rate threshold, or that the sleep window maps to wait duration in open state, you immediately signal to the interviewer that you don't just read high-level blogs. You actually implement, configure, and migrate real production systems. To truly blow your interviewer away, highlight the exact pitfalls, like forgetting that Resilience 4J doesn't time out calls by default like Hystrix did. If you don't explicitly configure a time limiter, a hanging downstream service will literally hang your service too. You should also mention the danger of self-invocation bypassing Spring AOP proxies, or how forgetting to ignore simple business validation exceptions can accidentally trigger your circuit breaker and take down a perfectly healthy integration. This right here is the operational battle scar knowledge they are hunting for. Finally, Section 4, the 4-step system design interview framework. You need a rock-solid structure for the actual interview itself. To make sure you don't ramble or get lost in the weeds during those short 45 minutes, we can structure the entire conversation using this proven 4-step framework. Step 1, clarify the scope. Never ever assume you know what design Twitter means. Step 2, sketch a high-level blueprint, your APIs, caches, databases, and get the interviewer's buy-in. Step 3 is the big one. Dive deep into 1 or 2 specific bottlenecks and apply those microservice patterns we just discussed. And Step 4, wrap up by honestly analyzing the trade-offs you made. Remember, during that deep dive phase, your primary goal as a senior engineer is to demonstrate your operational judgment when the system breaks. Literally, anyone can design a system that works perfectly when traffic is low and servers are healthy. The interviewer wants to know what happens during a network partition. What happens when the database goes completely down? Do you use a dead letter queue? Do you serve stale cache data? That is exactly where you win the interview. So, as you prepare to clear that 2026 hiring bar, ask yourself, are you ready to design systems that not only scale, but fail elegantly? Bringing this level of strategic, pattern-based thinking, combined with modern frameworks like Resilience 4J, is exactly how you prove you're the tech lead they need to hire. Thanks for joining me on this explainer, and good luck out there.